In Lesson 8, we're actually kind of going back a little bit to the properties we talked about in the beginning. So here are the properties that we have already discussed in class that you need to make sure that you know and have recorded down for your notes. So replacing numbers with letters is continuing, but now we're going to look at how that relates to our properties. So our first one, the additive identity or the property of 0. Any number added to 0 will result in that number. So for instance, 3 plus 0 will be 3. A negative 5 plus 0 is still negative 5. And then our formula that represents this property is a plus 0 will always result in a, or a plus 0 equals a. Next one, we have the multiplicative identity property of 1. Any number multiplied by 1 will result in that number. So 8 times 1 is 8, negative 10 times 1 is negative 10, and m times 1 equals m, or a number times 1 always equals that same number. Our next one is the commutative property of addition and multiplication. 2 or more numbers can be added or multiplied in any order and the result is the same. So 3 plus 2 is the same as 2 plus 3. 4 times 5 is the same as 5 times 4. And the way we demonstrate this as a formula is we'd say m plus n is equal to n plus m. So you see we have m on both sides and n on both sides. We just added them in a different order. And over here we have an n times y equals a y times n, which means a number times another number is equal to that number times another number if you just switch places. And this is only true if it's only addition or only multiplication. If there are any other operations involved in that equation, then this doesn't work. But if it's only addition, you can do it in any order, and if only multiplication, you can do it in any order. So I'd like you to go ahead and go to Lesson 8 in your book, which we have right here. Now, what we're going to do is we're going to look at how these properties apply to the problems in your book. So, we have a 4 plus 0 equals 4. 4 times 1 equals 4. 4 divided by 1 equals 4. 4 times 0 equals 0. And 1 divided by 4 is equal to 1/4. All of these statements are true. How many of those statements would be true if the number 4 was replaced with 7 in each of the number sentences? So let's try it. This would be 7 plus 0 equals 7. So we replace 4 for both. 7 times 1 equals 7. 7 divided by 1 equals 7. 7 times 0 equals 0. And 1 divided by 7 is the same as 1 over 7. Those are all true. So you would say all of them for the second one. Now, would the number sentence be true if we were to replace the number 4 with any number? Yes, that's true, except for 0. Now, the reason 0 wouldn't work is that if we replaced 4 with a 0, that would put 0 as a denominator, and you can't do that. That's not a real number. So this would be, which is what they're asking. If you replace it with 0, would it be true? And the answer is no, it would not be true. And what if we replace 4 with G? How would you write it? So we're going to look up here, and I'm going to actually do this very last one, which you can't see. So here are your answers. Yes, except for 0. And then you say no. And then down here it says, what if we replaced all the 4s with the letter G? Please write the 4 expressions below. Instead of below, we're going to write it above, so that you can see the way that the formulas are written when you're given a number. So it says replace the 4 with G. So we have a 4 plus 0 equals 4. So that means my 4 becomes a G. So that's a G plus 0 equals G. And then we have a G times 1 equals G, because that's 4 times 1 equals 4. And then we have a G divided by 1 equals G. A G times 0 equals 0. And 1 divided by G equals 1 over G. So that's how we would take these and write them as a formula. All right, so if you go over this next page, we're going to look right here, additive identity property of 0. And if you look at your notes, the additive identity property of 0 was if we added any number to 0, we'd just get that same number. So remember, a letter in math represents a number. Can we replace G with any number? So you could try it out. 1 plus 0, 10 plus 0 is 10. 100 plus 0 is 100. 5 5,000 plus 0 is 5,000. So this is true for everything. 0 plus 0 is a G. Negative 5 plus 0 is negative 5. So this is always true. And then the next one. It says choose a value for G and replace G with a number in the equation. What do you observe? So if we pick a number, let's pick a 3 plus 0 equals 3. The formula is true. And repeat the process several times, choosing different numbers. So 1 plus 0 equals 1. 10 plus 0 equals 10. 5 plus 0 equals 5. And you could literally go on forever and ever, because this property is always true. Any number plus 0 is itself. And will all values of G result in a true statement? Yes, it will. And write the mathematical language for the property below. This is the additive property of 0. So this is what you call this property, where you can add 0 to anything and just get the original number. So let's go ahead and go over here. We now have the multiplicative identity property of 1. So this is the language that we used in your notes, and that means that we can multiply any number times 1 and get that same number. So remember, it can represent anything. Can we replace G with any number? So 0 times 1 is 0. 10 times 1 is 10. 5 times 1 is 5. So yes, this is true. And then it says choose a value, replace it with that. So what do you observe? So we take a 1 times 1 equals 1. The answer is the first number, or whatever you said G equaled. And then will all values of G result in a true number sentence? Experiment with different values before making your claim. So this is always true. Anything times 1 is itself. So any number times 1 is itself. And the mathematical language for this property is that any number multiplied by 1 will result in that number. So any number multiplied by 1 will result in the number. And our last property is our commutative property of addition and multiplication, where you can change the order of what you're adding and you still get that same answer. So it says replace the 3's in these number sentences with the letter A. So here's my 3's. We have a 3 here, 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 and here. And then the rest will stay. So that means that 3 becomes an A plus 4 is equal to 4 plus A, or A times 4 is equal to 4 times A. And then it says choose a value for A and replace A with that number. So let's pick a different number. They use 3. Let's use 2. So this is 2 plus 4 is equal to 4 plus 2. Well, this is 6 and this is 6, so that's true. All right, up here, it says, will all values for A be true? And the answer is yes, it will be true. So with this property, it does not matter what number. If we are only adding and only subtracting, or only adding or only multiplying, that is true. Subtraction and division, you have to do it in the right order. But multiplication and addition, the order doesn't matter because of the commutative property. So the commutative property states that 2 or more numbers can be added or multiplied in any order. and the result is the same. Now, if we look below, we have a 3 plus 3 plus 3 plus 3 is equal to 4 times 3. And then we have a 3 divided by 4 equals 3 over 4. So right here, it has us replace the 3's with the letter A. So that means we'd have A plus A plus A plus A. So that's 1, 2, 3, 4 is equal to 4 times A, which is true. So if we're repeatedly adding a number a certain amount of times, we just multiply it by however many times we're adding. And then this last one here, we had a 3 divided by 4 equals 3/4. And the way we would replace that is A divided by 4 equals A over 4. So a division problem is the same as a fraction. So a fraction is a shorthand way of writing a division problem. And if you remember, when we find decimals of fractions, we divide them, and this is why. Because A over 4 is actually the same as A divided by 4. At this point, I would like you to go ahead and grab your problem set and complete that and turn it in.